All right, so let's continue on. So this is number 8. So number 8 is a pretty straightforward problem. So this is actually a density curve, and based on what data set or based on the type of problem that I give you, you should know if this represent a one-tail, two-tail, a two-tail test. So for this one, if you look right here, it's saying which of these graphs represent a left tail test. So either way, a left tail test, you know that the tail of the left side should be shaded. So all you have to do is just go around and like, okay, if the tail of the left side is shaded. So if we look at pretty much what we have here, the body is actually shaded and the tail is actually shaded. If we're doing a left tail test, we usually only want the tail of the left side shaded. So if you look at this one, the body is actually also shaded. So that wouldn't be a left tail test. So if we look at B is shaded the middle portion. So it didn't even shade the left side of the tail, it shaded the middle portion of it. So we know B is not the correct answer. So if we go to C, you look at C and you see that the left side of the tail is shaded. So this will be your answer for C. So hypothetically, if I would have wanted a right tail test, pretty much you'll have a density curve, and this one, the right side of the tail should be shaded. Hypothetically, if they would have asked you for a two tail test, in this case, since it's a two-tail test, that means it could either be less than or it could be greater than. So that means we're going to shade the right tail and we're also going to shade the left tail. So it's important to know which density corresponds to the left tail test, the right tail test, or a two-tail test. So that's it for 8. So let's do number 9. So number 9 is actually a pretty straightforward problem. So what you want to do is actually a researcher conducted a hypothesis test on the population proportion. Her known alternative hypotheses are that the null hypothesis of P is equal to 0.4 and the alternative hypothesis P is less than 0.4. So it says the test statistic and P value for the test are the Z is equal to negative 3.01 and the p-value is 0.0013. So, and this one will give us a level of significance, and remember the level of significance is also the type 1 error. So it's saying choose the correct conclusion. So this one's saying based on our significant level and the p-value, what should we conclude? So we first just want to compare the p-value to our significant level. So p-value is actually equal to 0.0013. My alpha is actually equal to 0.05. Alright, so this one is going back to some basic concept. We just want to compare this number to this number. So we want to see which of the two numbers is bigger. So is 0.0013, is that bigger than 0.05? And the answer that everybody should come up with is no, it's actually less than. So if my alpha is greater than my p-value, this means I should reject the null hypothesis, and we should state there is sufficient evidence to support the claim. So we just want to look at A, B, C, and D, and we kind of want to see which one represent that. So if you look straight off the bat, you can kind of see that C and D are not possible answer. The reason why they're not possible answer, because there is not sufficient evidence. And if you remember, we said there is sufficient evidence to conclude the claim. So we already know C and D are out. So let's look at A. So A say there is sufficient evidence to accept the null hypothesis that the population proportion is equal to 0.04. So for this one, there's one fatal flaw for this one. It says accept. So in statistics, we can never say accept because there's always a possibility that we could be wrong. So we kind of want to prevent that. And we just want to say if there's enough evidence or not enough. We don't really want to say that we accept something. So A is wrong. But let's look at B and see if B has all the good. So this will say there is sufficient evidence to conclude that the population proportion is significantly different from 0.04. So for this one is actually stating that we're not going based on ideas, we're going based on our evidence. So our evidence is showing that the alternative hypothesis should be right, that the P is less than 0.04. So for those reasons, B will be our final answer. All right, so let's do number 10. So number 10 is exactly the same thing. Well, actually, this one, number 10, where we want to say what does the p-value represent. So in this one, we already did this problem. It says the quality control managers think that there's a high defective rate of the production line, that the advertising value of P is equal to 0.025. She does a hypothesis test with a significant level of 0.05 symbolically. The known alternative hypotheses are as follows: that P is equal to 0.025 and that P is greater than 0.025. She calculated p-value for the hypothesis test of defect light bulb to be approximately 0.067. So it says choose the correct interpretation of the p-value. So if you remember for the p-value is always saying that, okay, this is the probability that we get this event or event that even more extreme than this event, given that the null hypothesis is correct. So this one telling me that the null hypothesis is that P is equal to 0.025. So for A, it says the p-value tells us that the probability of concluding that the defect rate is equal to 0.025, when in fact it is greater than 0.025, is approximately 0.067. So that one is not right at all, because it's saying concluding that the defect rate is equal when in fact the greater than 0.025 is approximately 0.067. So what we want to do, it has to say something in regard to more, more extreme. So let's look at B. It says the p-value tells us the true population rate of defective light bulb is approximately 0.067. So that one is incorrect. It's not telling us anything about it. C is saying the p-value tells us that the result is significantly higher than the advertisement value using a significant level. Once again, it's not saying that, it's just talking about the significant level and the p-value, comparing the two. So that one's something different. So D say the p-value tells us that if the defect rate is 0.025, that the probability that we will observe the percentage she actually observed or higher is 0.067. So this one is pretty much giving me all I want. It's telling me the fact that whatever observed observation she had, or higher than that observed observation, is 0.067. So that's why D will be the following answer. All right. So let's do 11. So 11 is asking us, when should we do a hypothesis test, or when should we do a confidence interval? So a confidence interval, sorry about that, let me get out of that. Confidence interval, we do it when the parameter is unknown. So we have no idea what the parameter is, and we kind of want to find it. So that's when we do a confidence interval. A hypothesis test, when we have a claim and we want to test it. So let's just recap. A confidence interval when we don't know what the parameter is and we want to figure out where does the parameter lie. A hypothesis test is whenever we have a suspicion of what the proportion should be, but we don't believe that it's actually that proportion. So let's look at number 11, and once we're done with number 11, we'll actually stop and then we'll continue on with a new video. So number 11 said the Business College Computing Center want to determine the proportion of business students who have personal computer PC at home. Because if this proportion exceeds 25%, then the lab will scale back a proposed enlargement of the facility. Suppose 300 business students were randomly sampled and 65 have PC at home. Should they use a hypothesis test or a confidence interval to answer this question? So for this one, they're not really looking for a parameter because they kind of already have what they think should be the proportion. Because if it's 25% or less, they don't have to renovate the facility. They could just leave it as is. But if it's greater than 25%, then they have to do some renovation. So they already have kind of a proportion in mind. So for this one, we're going to say they're trying to claim a test because they're trying to test to see if more than 25% of the student have a PC at home. If they do, then they have to do enlargement of a facility. So for this one, it should be A. Alright, so we'll stop the video right there and we'll conclude number 12 and on the next one.